Your body just cannot take oxygen because what is supposed to take the oxygen has switched off. It says I am not going to bind with oxygen, and you die immediately. That's the way it works. So now you tell me, by mistake, if your friend has consumed cyanide, what should you do? I am sure nobody will. But what do you do? What do you do? The best thing to do is to make him drink a lot of water so that that guy vomits. So that whatever is remaining in the stomach goes out. The other thing is to immediately take him out in open air and give a lot of oxygen. So that whatever areas are not really filled up, at least some oxygen can go in. The other thing which people do, people give some oxidizing agent so that the iron 2 gets converted to iron 3. And if iron 3 gets converted, then some of the cyanide may come out. But chances of living from cyanide is very low. People generally don't survive. So I mean, if you don't know any chemistry, if you don't know how cyanide will bind with porphyrin, if you don't know that electronegativity difference between carbon and nitrogen, then how will you do the reaction? How will you understand how things work? So you really need to understand chemistry. That is the point. Any questions? Yeah? Any questions, please? In fact, this hemoglobin is a wonderful protein. The way hemoglobin works, this is known as cooperative mechanism. If I have time, I will talk about it. The way it works, yeah.
Sir, what if we try to break the...
don't call me sir, my name is Ayan. Yeah. And what is your name?
Aradhya.
Aradhya. Okay.
What if we try to break the CN and porphyrin bond?
CN and porphyrin bond is like janam janam ka saath hai tumhara hamara. It's like that, and they are too much friend. I mean, in other words, the iron carbon bond in cyanide is about 200 kilocalories per mole. If you want to break that bond, you have to heat it up at 1000 degrees centigrade. But how will you heat up at a person at 1000 degrees centigrade? A person will die if the temperature crosses 100, 105, 106, 107 Fahrenheit. You see the problem? That is why cyanide poisoning is so... Good question, Aradhya. Yeah, anybody else? Why only boys? Why no girl is asking any question? I don't like this. I don't like. Yeah. Now some girl has to ask the question. I don't believe boys are smarter than girls. They can't be. Girls are more smart. They are genetically, yes, girls are more smarter than boys. I am very serious. They have to be. Boys can do only one thing at a time. Girls do multitasking. So God has made them smarter. Yeah, any questions? Yeah? Okay, next question will come from her. Okay. So the next example, see, I give you various, in other words, this is called bird's eye view. So I give you various examples. I know by the end of the day you will forget. Slowly you will forget. Doesn't matter, but some of it will stay back. So next time when you see in the newspaper, when you see somewhere else, I had read it somewhere, I know something. Right? And by the way, what is this generation called? IT. Information technology. So everything depends on information. If you don't have information, you cannot survive in this information. You need to grow up fast. In other days, we could say, nahi, musko malum nahi, mujhe janna bhi nahi hai. You guys have to know everything. No chance. Things are very, very complicated. Yeah. So this example which I will talk about, it is again a very old thing, but now we are making a lot of use about it. So I will talk about ceramics, and I will go from pottery to superconductors. What is ceramic, by the way? Your teacup. Teacup, saucer, these are all made up of ceramic things. Right? Yeah? Now tell me please. Yeah? So for example, and for how many ages people know these ceramic things? For example, this is Indian terracotta, Hanumanji. You see? And this is Song dynasty in China. And these are terracotta, beautiful art. Now of course, as you know, so how do you get ceramics? You take clay and then heat it up to high temperature. This is exactly the way pottery is made. How do you make pottery? Mitti liya, very high temperature you burn it and then you get clay. And you mix it with various things to get various textures. Right? Now as people have found out that this material is a wonder material because you can make superconductors. Now, as you say, before I talk about superconductors, I have to talk about conductors. So, what is an example of a conductor? What is the best conducting material of electricity? Silver. So, what happens if you take a silver wire, right? You create a potential energy difference between them, and what happens? Current will flow, right? So, the more voltage you will put, more current will flow, and there is a proportionality constant, and there is proportionality constant is called the resistance. So whenever you put a potential bias between a wire, there is always a resistance. In other words, physically think about it. This is exactly what resistance is a kind of friction. Why friction? Think about your silver atoms. In a wire, silver atoms are placed. Now what are you doing? You are giving a field and making the electrons jump from another to another. But then this electron is being loved by the nucleus of that atom. So if you are going to drive it away, the nucleus will say, "Aaja, aaja, mere paas aaja." But then you are going to take it away. So then that guy will sing, "Aaja, aaja, main pyar tera." That song it will sing, right? So as a result, there is a resistance. So that is a major problem in our world, that whatever electricity we produce, we have to transfer it across the grids. And there is lot of resistance, and as a result lot of wastage. And how do you know wastage? In fact, you can do that experiment, right? In fact, you have already seen it, right? If you put your TV for a long time, you will see it gets heated up, right? Why it gets heated up? Those wires are getting resistance, and when it gets resisted, there is thermal motion. As a result, the temperature goes up. And of course, as a result, this is a wastage of power, because you wanted it to be producing electricity. But this is a waste. So what people have done, has anybody seen this train? This is a very famous train. And what is this train called? Maglev. And what is the full form of the train? Maglev means magnetic levitation. Levitation matlab, this guy is doing levitation. Right? You can float. That is exactly the way this train works. So what they have done, they have these electrical tracks, they have the metal tracks. On that they have coated it with superconducting materials. So if for a superconducting material, there is no loss of electricity. So when electricity will pass through this ceramic materials will become superconductor. As a result, a superconductor is known to be an ideal diamagnet. So it will repel. So it will repel anything which is any metal which is going over it. So in other words, a train which is moving over the tracks will be floating. So as a result, it gets a speed of 600 km per hour. In fact, some of you can even do this experiment. If you put liquid nitrogen here, and you will see that this iron will float over another iron. This is an example of magnetic levitation. Can you go to the next? Okay. So of course, the problem with superconductivity is one of the greatest challenges of mankind. Why greatest challenges of mankind? Because superconductivity, if you are able to get, there will be no loss of electricity. So the production of electricity will become almost free. Now, the first discovery of superconductivity was made in 1911. And what was the temperature in which it was becoming superconductivity? 4.2 Kelvin. What is the temperature in the room? What is room temperature? 300 Kelvin, 290 Kelvin, whatever. So of course, if you want to make any material, you need to make a superconductor which works at room temperature. And that is the challenge. So people are trying for such a long time to make a superconductor which works at room temperature. For example, this was discovered by Camerlingh-Onnes. He got Nobel Prize for this. So you go from 4 Kelvin to 20 Kelvin. So over the period of time, people have actually gone to temperatures higher and higher. So eventual target is we go down to temperature at room temperature. At room temperature, they are able to make something which is a superconductor that will be used. And how and what are these materials? The highest temperatures available are all for ceramics. Ba2CO3O7 ceramic, these are all ceramic compounds. People have also made organic superconductor. So that is the idea. So in your generation, you have to make materials which are superconducting at room temperature. And that is going to be one of the greatest challenges of mankind, because then there will be no loss of electricity. So electricity which is produced in America can come directly here without any loss. That is something very important. In fact, people are making maglev train works on that technology, on superconducting. That's that. Any questions, please? Yeah. No, but no, I am not supposed to take your question. First the Federal 6. Yeah. Ladies, please. No woman has any question? Nobody has? No questions from ladies? So, yeah? Nobody? I mean, I think they are very shy. Or you find everything okay. I mean, if you don't have any questions, it's okay. No, it's strange. I mean, nobody asks questions. Please, yourself, any questions, please? Yeah. Yeah. Since nobody else, please go ahead. Inside.
Sir, you said that it will be a challenge to make this superconducting
Material at room temperature.
Then isn't superconducting material used for this maglev train working at room temperature?
What they do, they run liquid nitrogen under it.
But that's the atmosphere. So.
No. See, they have a, see, this is the track, right? On the track you have the superconducting material. Under it, they run liquid nitrogen through as a tube, so that the temperature is known. The idea is to make something which is room temperature. Right? Yeah. What's your name? Why don't you introduce yourself? Yeah, superconductors are made. For example, this is a very important area of research. In other words, how do you make a superconductor? Superconductors are made by making ceramic materials, heating it up, and then cooling it down. This is called thermal annealing. There are these very specific procedures by which superconductors are made, by annealing methods. And various superconductors have the various